Prove that when the sum of the squares of any two consecutive odd numbers is divided by 8, the remainder is always 2. So the sum of the squares of any two consecutive odd numbers. Okay, so consecutive odd numbers. If my first odd number is 2n plus 1, the one after that would be 2n plus 3. And we want the sum of the squares of those consecutive. So these are the squares of those consecutive odd numbers, and this is the sum of those. Right, let's expand these brackets out. So we've got 2n plus 1 times 2n plus 1. And then we'll also have the 2n plus 3 times 2n plus 3. 2n times 2n is 4n squared. 2n times 1 is 2m. 1 times 2n is 2m. 1 times 1 is 1. Two n times 2n is 4n squared. 2n times 3 is 6n. 3 times 2n is 6n. 3 times 3 is 9. Collecting up the like terms now then, so we've got the 4n squared plus 4n squared is 8n squared. The 2m plus 2m plus 6n plus 6n. So 2 plus 2 plus 6 plus 6 is 16n. And then we've got the 1 plus 9, which is 10. So this is my expression for the sum of the squares of two consecutive odd numbers. And I need to show that when it's divided by 8, the remainder is always 2. Now, I'm going to do something now that's a little bit strange. We wouldn't usually do this, but it's going to help me to answer this question. I'm almost going to unsimplify this. This 10 on the end there. I'm going to split that up into an 8 and a 2. The reason why I'm going to do that is because this can be the remainder 2 now that we're looking for. The remainder is always 2. And this is divisible by 8. So by rewriting the 10 as 8 plus 2, obviously in a longer form, but it's going to be more useful to help me to show that the remainder is always 2. Because I can now say that all of this is divisible by 8, I can factorise an 8 outside there. The 8 times the n squared is the 8n squared. The 8 times the 2n is the 16n. And the 8 times the 1 is the 8. Plus the 2. And I can now say that this is divisible by 8. And it leaves the remainder of 2.